In this video, we're going to look at generating sequences using a rule. A sequence, remember, is any list or set of numbers that follows some specific kind of rule, and that rule could be absolutely anything. And there are many ways to describe a sequence. Usually we describe it in words such as add 2 each time or multiply by 7. But often this can lead to some ambiguity because we don't know where to start. So we can use an algebraic rule, and this is usually called the general term or the nth term. And the way we write this is to show that we're talking about the general term, we use the notation un. Now, u is used to represent any term in a sequence, and the little n, the subscript n, is going to be used to tell us which term we're dealing with. So let's look at an example, and it should become very clear. So if we have our general term is un equals 3n plus 2, from that we can work out the first term by using n equals 1. When n equals 1, we find what's called u1, the first term, and we do 3 times 1 plus 2, which gives us 5. If we wanted the second term, we do n equals 2, and that gives us u2, which is 3 times 2 plus 2, which is equal to 8. If we wanted the third term, we do n equals 3, which gives us u3, which is 3 times 3 plus 2, which gives us 11. But the really good thing about this kind of rule is that we can work out any one without knowing all the previous terms. So if we wanted to know the 50th term, to find the 50th term, we would use n equals 50, and that would give us u50, which is 3 times 50 plus 2, which is 152. So with a general term written like this, we can substitute any value for n to find the term in that position. For the 50th term, we substitute n equals 50 into our general term. Now, general terms come in many different types. Here we've got what's called linear one, 3n plus 2. We can also see general terms that look like un equals n squared plus n, and that is called a quadratic sequence because it has a n squared in it. But we do exactly the same thing. If we want to find the first term, we use n equals 1, which this time gives us 1 squared plus 1, which is equal to 2. If we want the second term, we do n equals 2, which gives us 2 squared plus 2, which is equal to 6. If we want the third term, we do n equals 3, which gives us 3 squared plus 3, which is 12. And if we wanted, let's say, the 10th term, we would do n equals 10, which would give us 10 squared plus 10, which is equal to 110. Another one we could look at is a general term that has a fraction in it. So un equals 1 over n. We work in exactly the same way. If we wanted to know the first term, n equals 1 gives us 1 over 1, which is just 1. If we want the second term, it's n equals 2, which is 1 over 2, or a half. If we want to know the third term, we can do n equals 3. We get 1 over 3, or a third. If we wanted the 50th term, we can do u50. We put n equals 50 in, and this time we get 1 over 50. One final example then, we can do a general term like un equals 3 times 2 to the power n. So this time n is in the power. But we work in exactly the same way as we have with all the others. If n equals 1, we get u1 is equal to 3 times 2 to the 1, which is 3 times 2, which is 6. The second term, when n is 2, we get u2, which is 3 times 2 squared, which is 12. If we want the third term, we get n equals 3. We get u3 is equal to 3 times 2 cubed, which is 3 times 8 is 24. And if we wanted the 10th term, we do n equals 10. We get u10, which gives us 3 times 2 to the power of 10, which is 3 times 1024, which is 3072. So general terms can come in lots of different styles. They can be linear, quadratic, they can have fractions, they can have powers in. But always, to find the third term, you find u3, so you replace all the n's with 3. To find the 8th term, you find u8, so you replace all the n's with 8. And that's all we have to do to generate a sequence from an algebraic rule. No matter how complicated it is, we just substitute in the term number for the n's in the rule.